Okay, so today's homework is going to be a little bit harder than last time. We're going to learn how to solve exponential functions using logs. Okay. So we're going to learn how to solve exponential functions using logs. So first of all, let's start with a fairly easy one. Okay. I have 2 to the x equals 30. And I want to know what x is, and I want it to be an exact answer, which means no rounding. Okay? So there's really no way to do this. I can't take the x root of it. So the only way that I can solve this is by using logs. So I'm going to use log base 10. It really doesn't matter what log base you use, but that's usually the one that we use unless you're told otherwise. So I'm going to go log 2 to the x equals log 30. Okay. Now I can bring the x outside of the log. So I have x log 2 equals log 30. Now I'm going to solve for x by dividing by log 2. And I have x equals log 30 over log 2. Now, believe it or not, this is a number, okay? Log 30 is a definable number. I could put that in my calculator and get a decimal out of it, but this is a number. So my answer, as an exact answer of x equals log 30 over log 2. I can't simplify that any further without rounding. So, all right, so that's a fairly easy one and usually simple to see. Let's go to the next example. Number 2. I have 200 times 2 to the 0.04t equals 6. And I want to solve that for t. So before I even start thinking about logs, let's start thinking about what can we simplify on this. So I'm going to divide by 200, get rid of that. Okay. 200s cancel. I'm left with 2 to the 0.04t equals 0.03. Okay, this is an exact decimal. I just put it in my calculator and that's what it spit out. Now I'm going to use logs. Log of this side and log of that side. And now I can get rid of the exponent since I have logs on there. So I can go 0.04t log 2 equals log 0.03. Okay. All right, now I need to get the t alone. So I can actually divide by 2 things at the same time. I can divide by the 0.04 and I can divide by the log 2. This is all going to happen at the same time on the other side of the equal sign. So it's dividing by 0.04 log 2. Now this one, I believe, it doesn't ask for an exact answer, it asks for an approximation. So if it asks for an approximation, we can find this using decimals. So I have t equals, now I just put this in my calculator, again the log button works just fine, log 0.3 divided by 0.04 log 2. And my calculator spit out approximately, again these are going to be irrational numbers, 126.472. And 3 decimal places is usually sufficient. Okay, now we're going to talk about some natural log side of this. So I want to go over a rule. I'm going to go over a rule on this. This should be fairly easy. I want to identify the idea that e to the x equals a. Okay, if e to the x equals a, then x equals the natural log of a. So if we follow that rule, we're going to use that rule for our examples. So example 1 for this part. Okay, the first part of your homework we just talked about. This is the second part. Okay, so example 1 says e to the x equals 30. Okay? And I want to know what this is approximately. So I'm going to say, since I know that e to the x equals 30, I know that x is going to equal the natural log of a, oh not a, sorry, that was my formula, natural log of 30. I pop that in a calculator and I get x is approximately 3.401. Okay, so that again, it's just a rule that we can follow to find our answers. A lot of these are going to be asking for specific answers, even if they're approximations. Okay, so let's do one that's just a little bit harder. Okay, e to the x over 3 equals 21.879. So again, I have the rule that says my exponent equals the natural log of my number that it equals. So we're going to go x over 3 equals the natural log of 21.879. And now it is just algebra. Multiply by 3 on both sides. And I get x over 3. Or no, my 3's gone now. Okay. X equals 3, natural log of 21.879. Again, pop it in the calculator, and I have x is approximately 9.257. One more example. I have 20 e to the 4x equals 0.0382. So before I can use this rule, this has to be, the e has to be alone, so I'm going to divide by 20 on both sides. And I get e to the 4x equals 0.00191. Now I can take the natural log of both sides. Well, no, I don't even have to do that. I can just know that this is going to equal the natural log of that. So I have 4x equals the natural log of 0.00191. Divide by 4. X equals, again, prop it into your calculator. And I have a negative 1.565. That's it. Homework is coming on in Moodle.